Okay, thank you everybody for joining us. I'd like to first talk to you about our Apigee Insights Deep Dive. So we're going to be giving a very detailed overview of how Apigee Insights, the product, works and the problems that it solves. So I'd like to kind of do an intro.
My name is Young Kim, and I'm a solution architect for Insights, and I'll be walking you through some of the product demos today.
And then I'm Alan Ho. I'm the product manager for Apigee Insights. This webinar is going to be recorded, it's going to be put on YouTube, and it's also going to be on the SlideShare. So I'm going to hand it over to you, Young. Can you tell us like what kind of problem is Apigee Insights solving?
Yeah, Insights is definitely a tool for data science and all that, but really it comes down to this, right? When you look at our customers who are working with their customers, right? This illustration sort of depicts where they are, right? They're on multiple devices, constantly on, also being constantly bombarded by offers and things like that. So it's a real challenging environment to build relationships around for our customers with their customers, right? So one of the most challenging aspect is that right now, consumers will tune you out if your offers, whether it be on the website or a mobile device, are not relevant. In fact, 74% of the recent survey said they would they're very frustrated with companies that really don't personalize their experience, right? On the flip side though, close to 80% said they would be ready to willingly share their data if there was useful sort of information that they could get from the retailer and so on, right? So to help them serve them better, right? That's the idea, right? And I wanted to kind of call out these two very common sort of retailers, like Target and Amazon. And now this is just my personal experience. I love these merchants. I purchase from them a lot. But when I visit, for instance, Target, right? For me, anyway, it's really about getting in and getting out. You know, like I know what I want, and I just kind of buy it and then bring it home, or and so on, right? But with Amazon, it feels a little different to me. Right? Maybe it's the recommendations that they're offering and so on, that when I visit and I see an updated, personalized recommendations, and then I tend to kind of browse more. I don't know, that's my experience.
So I think what you're saying, like, and we talk from an emotional perspective, right? Like one of the things that we found with a lot, not just retailers, but almost every single app or vertical is that they're trying to play on the emotion of get free stuff. Right? Whereas what you're saying is that companies that do personalization right, they're using multiple triggers. So the emotional trigger of learning about new things, right? That's where all the recommendations and things of that sort. Right. You know, piquing our curiosity. Yeah.
Right. And I thought this was an interesting quote. Now this is dated. This is 2012, right? But again, on an interview with Forbes, it's talking about how Amazon is so confident about their ability to do personalization, they don't even do sort of the traditional customer segmentation anymore. Yeah. Right? So they're way beyond that today, right? But that's not to say that segmentation is not important, right? So if we were to take a step back, what does a complete personalization solution look like? I think part of it still, retailers need to focus on doing customer segmentation right? But also, you need to embrace analytics on big data, predictive analytics, right? Where you can do recommendations per user and so on, and do much better targeting through prediction, right? But also, that's not enough either, because all that has to also be supported by a real-time server. Ability to interact in real time and update that information as the user is experiencing your website or a mobile app.
And I find actually, having worked at Amazon, I personally feel that retailers or any kind of app developer or any kind of people with a digital experience needs to be much better.
Yeah.
And here's the reason why. Everybody talks about Amazon as being the biggest store and etc. But the truth of the matter is it's not an apples and oranges comparison. You use Amazon on a very frequent basis, so they don't actually even bother, even though they have pretty good recommendations. Right. They don't even bother because they know that you're going to come back anyway for buying something else. They turn into a habit. Right. But if your app is not one of those kinds of apps, let's say luxury retailers, you don't go off and buy a $500 handbag on a regular basis.
Right.
It's even more important to have a much better personalized and experience than an app that you use on a regular basis.
Right, makes sense. Yeah, great point. And retailers know this. In fact, this is a recent survey in 2014. Where they surveyed customers, 86%, right? Really large number of customers say they are impacted or they make decisions because of the personalization that was offered by a merchant, right? And then the flip side, from the merchant's perspective, these numbers, 74% said that they're getting greater sales because of personalization, and 61% reporting higher profit because of personalization. So there's a real push towards personalization, I think. Right?
Tell me the reality of that.
Yeah. So
what's the rub here?
So I did some additional searching online and looked at a couple different reports. And they all seem to converge on this number of about 30%, only 30%, right? 25% actually are doing even just web-based personalization today, right? In fact, the large majority, 70 to 75%, according to these statistics, of retailers are really having a hard time because they don't know how to do this, right? Because of the complexities around it. Right? Yeah. So this is really
the silver bullet.
Exactly why I'm so excited about Insights, because Insights is a platform, right? It allows the enterprises to take the consumer information, the profile information, along with all the wonderful behavior-based data, all the interaction data that they're collecting, marry that together, and then offer the ability to do behavior-based segmentation, which is different from just your traditional profile-based segmentation. So allow you to do behavior-based segmentation for much better targeting, as well as behavior-based predictive modeling, which is a really challenging problem. So ability to actually take into account the patterns that exist in your historical behavior data, right? To do predictive. And then all this is as an integrated platform with our edge real-time serving layer.
Okay. And just to be specific, like from a use case perspective, it supports both outreach to get people into the app,
right.
So push notifications, emails, even call center, even people calling you, right? That's a use case. To get people engaged,
right.
And then once they're engaged within the application, be able to use analytics for recommendations, site personalization, et cetera. So really, we're trying to actually bridge the multiple experiences, because if you don't have multiple experiences all bridged using the same common analytics, same common recommendations, same common system, it's very hard to get a consistent experience.
Yeah. So actually, I want to show you a couple of apps that we developed. One is a web app that shows personalization, but also real-time updates happening as the user is interacting with the website. And I also want to show you a quick demo of a mobile app that we developed within actually a couple days of starting with raw data to show that as well on the mobile app. So what I wanted to show here is a Burberry website. It's not Burberry. They're not actually using our this particular recommendation app, but it's just wanted to demonstrate the art of the possible here. So in this scenario, what you're seeing is their website, and what I'm going to simulate is a user coming in, and the slider app on the bottom is what the user first experiences. It's a real personalized set of recommendations based on the model that we built for that user using their profile and past behavior information, right? So for instance, if I were to switch the user to another user, let's say user 10, their initial experience would be much different, right? So the recommendation that's coming up is personalized for that. The second thing I want to show you here is as the user interacts on the website, the recommendation system learns what they're interested in, right? And updates the recommendation now. So I've clicked on belts a couple of times. Now the recommendations that are coming back, right, is more related to belts and maybe even a tie in this case. It's like smart enough to know that,
Because I'm a guy, and I'm buying an accessory like a belt. I usually want to deck myself out with other accessories like a tie.
So that's a simple sort of, it's simple, but I think it illustrates the ability to take in personalized recommendations and then updating that real time.
Okay.
So another demo that I wanted to do is a mobile experience where we created a sort of simulated a real a loyalty app, right? Where a consumer might be interested in sending the offer based on their location, right? So what you're seeing here is I'm going to be simulating a couple different users and a couple different locations, right? So for user X, first user, based on, again, their prior purchase history and behavior, the offers that come back for this location are things like this: McDonald's, Dunkin' Donuts, and so on. So if the user were to now move to a different location, let's give it a second to update, based on that user's updated information, the recommendations that will come back will be updated. And I think it's just cash here.
Oh, there it is.
There we go. Okay, so let me go back. This was the original. So you have McDonald's. They really like McDonald's, but Olive Garden and Dunkin' Donuts, they move slightly, and then you get a different set of recommendations. But also, if you're you're in the same location for another user, let's say, they'll get a different set of recommendations coming up based on who the user is. Right? So it's ability to now take in real-time context in terms of location, but you can easily incorporate things like weather, right, as well, right? Other factors that, as you're interacting with the device, that you can make an adjusted recommendation, right, based on that.
So why don't you show me a little bit, like underneath the hood, like how you would actually go off and do this using Insights.
So Insights, as I mentioned, is a platform for both data scientists, maybe even a developer wanting to build predictive models, and data analysts to start exploring data and creating, understanding behavior, creating models, right? So this first round of demos, I'm just going to keep it high level and talk to you about some real interesting things that Insights can help you do first off the bat, right? The idea of customer journey is a real important concept for a lot of retailers to understand how consumers interact with them across channels, right? So in this instance, I'm going to walk you through what that looks like in Insights. So we have this ability to visualize paths, right? So paths signify, again, how the consumer is interacting with you across these different channels. And one of the things I can do is start with, and I could actually explore these paths forward or backwards in time. I'll just do a simple go forward in time analysis. So here, it's saying these are the top ways that my consumers interact with me right off the bat. So for instance, people like to visit the baby products department within a store. Then I can go forward in time and what do the people do next, right? What do my customers do next? Some actually end up buying baby products. Others come back to the website and start browsing. What do they do after that, right? Others actually purchase, but a lot of them come back to the store, right? So they're showing a lot of interest based on their behavior, but then they're not taking any action. So
And just a quick point over here, what you're seeing, this kind of pathing capabilities, it's hard to get out of the box from a lot of BI tools like Tableau, etc. There are these kinds of visualizations and tools like Omniture or Google Analytics, but they don't take in all your channels.
Right.
They don't take in your store data. They don't take in your store transactions, things of that sort. So the unique value prop over here that you can do with Insights Journey Analytics is that you can leverage all your digital channels, whether it's traffic from your web, from your store, from your APIs, from your Internet of Things devices, and visualize the interaction across everything.
Right. And so once you've identified a path, let's say, another thing you can do within the tool is I can actually profile particular visitors based on their demographic information, let's say. So this is sort of the typical set of information that a retailer might gather about their customers. So I can see things like based on frequency of age group. So I notice here that, most of these folks are younger parents, let's say between 30 to 35 years olds, right? I can also look at, for instance, based on their gender, right? These are their frequency. Right, so most are female, is to be expected, but I do have some population of young fathers in here, right, that are shopping, right? And so this is great and all, right? So I'm understanding some behaviors, I'm able to identify who they are, but
now we want to target and we want to take some action, right?
Right, so I'm going to walk you through how the tool actually helps us to target as well. So we've understood our customer base. I can actually create a targeted list. Here, what I'm saying is I've identified the behavior path that I'm interested in. Right? I've identified that. Now, I'm going to continue to step 2. And actually, I'm interested in young parents.
Yeah.
Right? I'm going to add that to my filter. But also, I'm interested in men. Right? So now I have behavior-based profile as well as behavior-based segment as well as profile-based segments. Right? So that allows me to then to be much more precise about the messaging, about the offers, and so on.
Okay,
right?
So you can basically use this to create either a push notification or an email that's targeting guys who are quote unquote indecisive. You see they're going to the store, they're coming back to the website, and coming back to the store again.
Right.
You can create some sort of targeted message like, come back to the store one more time and we'll give you a free biker baby t-shirt.
Yeah, right. That's the idea, right? So in fact it could be exported to our backend, a data store, to be exposed as APIs for external consumption, or as a CSV file to be exported out to ExactTarget or something like that.
And we had a number of customers who leveraged this tool to integrate with their own email notification, their email system, namely tools like ExactTarget.
Mm-hmm.
We've also tried it out with Marketo as well. So you can export these lists, let the data scientists and the analysts create these really, really good lists, and then have the marketeers be able to use the tools they like Marketo or ExactTarget, to generate high quality emails and targeting.
Right. So that was one aspect of insights that allow you to really understand customer behavior, create segments, and do targeted messaging around it. The other aspects that's really unique about insights is to be able to quickly build these behavior-based predictive models, whether it be for recommendation or for their targeting itself, right? So for that, I switched over to our modeling workbench. It's going to look very familiar to maybe a few of the data scientists that are out there. It's R-based, right? So it's the R console, right? Now, let me just be clear here. We're leveraging R as the UI, but we're not actually running R-based algorithms or models here. In fact, what we're doing is here, we're connecting to the Insights library and connecting to the Insights server so that we're actually leveraging the algorithms that we've developed for doing behavior-based analysis in the modeling, right? And what we did was we streamlined the modeling process. Now there's a lot of comments that I added in my script, but it's basically maybe a couple dozens line of commands.
I think it's 15.
15 commands, okay?
15 commands.
Yeah, right? And so it's about connecting, naming your project, pointing it to the data set that I'm going to be working with. In this case, I've got both a profile-based data, right, where it contains things like age group, gender, and so on. But I'm also integrating the behavior-based data that's coming from my interactions data, purchase interactions. Right?
Okay, so this is like store transactions.
That's right. In fact, I will go a little deeper into show you the raw data and how I actually created the model that you saw that we demoed on the mobile app. Right? But just wanted to give you a quick overview.
Can you show me like a side by side of like how you traditionally do it, just from a flowchart perspective?
Yeah. So this is really a good point. When you're doing traditional sort of machine learning or based predictive analytics, right? A lot of the work that needs to be done, apart from cleansing the data, let's say, right? Certainly that takes a lot of work. But 80% of, I think, what data scientists do is figuring out the relevant feature, what they call a feature set. What are the variables, the input variables that I'm going to use in my model, right? You have to explore that, right? And to do behavior-based analysis, the data scientist has to do even more work to take previous interaction data and search for these patterns so that I can include that in my model, right? And that's what you're seeing on the left, right? So you start with the data extract, spend a bunch of time doing feature extraction, right? Especially behavior-based feature extraction takes a tremendous amount of effort. And then you build a model, let's say, for who's most likely to purchase a category X, right? A single model for each category, right? Maybe iterate and so on. And that can usually take weeks or months to do. Now, comparing that to the insights approach, right? Yeah, there's data extraction, but as far as feature selection goes, especially around behavior, that's where the machine learning kicks in. It'll search the relevant behavior patterns in the data set that I identified and automatically apply those patterns and learn those patterns when doing the prediction. So that automated sort of feature selection on behavior is very helpful here for data scientists.
Okay, so brass tacks, show me, I want to add call center data into my, my model.
Great. So going back to the original script, right? You would do that by simply changing a line of text here. Basically, we're going to use the profile data as is. Right. Well, this is the original interaction data that I'm using.
Right. Yeah.
So by identifying, okay, now I want to use a store visit transaction or interaction. So you just simply point to that, right? I don't have to do any feature selection around what's the, that's right.
Okay.
Right.
Okay. Cool.
Yeah.
Okay, cool. So I think that's pretty innovative because now you're not having to, I think underneath the hood, at the lowest level, how we design the system is that underneath it's very much based on NoSQL. So there's no new database schemas that you need to update. You can just add a new activity stream into your model immediately, and then finally get it published. So can you show me that last
Yeah,
portion?
so once the model has been built, right, coming back to our Insights UI, I can go to my Predictions tab. And this is where the scored results are stored and available, right? So I can simply choose one of these model results, and I can say export to BAS, right? And then test my connection. And so what it's saying is, now I want to expose these results as APIs, right? And when you do that, I'm going to walk you through API BAS data store.
And just a quick intro to BAS for the people who don't know about it. This is our backend as a service. So it's if you think underneath the hood of backend as a service is a NoSQL, Cassandra, and Elasticsearch data store. Very, very high scale, very easy to use from a developer perspective to build applications on top of.
So what you're seeing here is this, again, the data itself is organized into catalogs and collections. So we're looking at data. Here's the recommendation output that I've saved in this particular collection. And let me hide the details. So for each user then, I can expand this. And what you see is the user ID, right? Who they're most likely to interact with next, and their score value, right?
So when you show me, this is the data that's backing that mobile app you showed me.
Right.
Showing all the different location, based on your location, which are the likely merchants that you would actually go to.
That's right. That's right. So, and in fact, here's the other collections called offers. This is where, for instance, the merchant's offers could be stored.
Okay.
Right? So in this case, what is Chick-fil-A offering as an incentive?
Okay.
2x the points and so on, right? And that's what you saw in the mobile app, right? The offers coming through.
Cool. So, can you kind of help me conceptualize data scientists versus developers and how that all interacts?
Yeah. So that mobile app that we developed, right? There was a team of 3 that we worked together on, right? So this is what we call digital value chain. And you build this out, okay. So there's 3 three of us that worked on this together, right? And it really literally took us less than a couple days, and partly because we have side jobs, right? Or doing other things, right? So I played the data scientist. I took the raw data and built out the recommendation model, right? And I worked with our API developer who took, once I've exposed that to API BAS, he wrote up the APIs that exposed all that insight out. And then we have an internal mobile developer who just simply took that and created that mobile app you saw. So it really, if you look at this, right, it's really about delivering that user experience. The person on the left, right, is the most important person in our perspective, right? It's the end consumer of our apps and so on. And we really want to make an engaging app, right? But on the back end, it's supported by data scientists, API developers, as well as app developers, right? And it's a single, and we all use the same, single platform, unified platform, right?
Yeah, and I think this is a really important point because, you know, any large organization has a lot of teams and a lot of silos, right? You need to have, and in fact, data scientists, there's some statistic out there that shows that data scientists to developers is like a 1 to 1,000, right? In a lot of ways, data scientists are kind of like unicorns too. So, you know, making those data scientists really, really effective and giving them the tool set that allows them to do the predictive models and outputs easily, and giving the developers the tools that also to consume what the data scientists do is really, really important. That being said, what we've done from a design perspective for Insights is that we've kind of made the experience of creating a model doable by even just a regular developer. By taking a lot of the hardcore data science steps out, for example, the feature extraction, etc., things that, you know, regular developers don't do on a day-to-day basis. We built a system that just regular developers can also build models too. So if they don't have a data scientist, it's still tractable for them to actually do. And we've actually added insights. So all the UI that you just saw there and our libraries, etc. We've added to Apigee Developer very recently, so that developers themselves can kind of try this out.
I wanted to highlight some of the features of Insights again. We released the self-serve for just anybody to sign up and get access to, right? A couple of features I want to, as you sign up for it, there is a recommendation API tutorial that will walk you through step by step from the raw data that we've actually loaded for you here under retail transactions, right? So we kind of preloaded some interaction data for you so you can quickly go through the tutorial and starting with raw data, experience how to do journey analytics, how to build those models, do the predictive, how to expose that to API BAS, and take that step further and actually to build out the recommendation APIs themselves, right?
Okay.
Yeah, so that's out there for you.
So one of the questions that we got via email though was, what's our secret algorithm? Tell us the secret sauce.
Yeah, so let's spend a few minutes. I'm going to get a little geeky here.
This is a deep dive, right?
Right. So,
and I think a lot of people in our audience that are all computer science majors. So let's go get geeky.
Yeah. So, and I really actually love to talk about the technology here because I think it's really unique. Just personally, I've come from building models on my professional career, right? Using all the tools that are out there. SAS, SPSS, actually started R even, right? What's really unique about Insights is the fact that, I keep using the word behavior a lot, right? So if you look at, if I were to summarize Insights, this is what it would be. It's innovative machine learning, right, approach for automatically detecting behavior-based pattern based on the consumer behavior at scale, right? How we understand big data today, right? Maybe about 5% of that data is made up of customer profile data, right? And really what makes big data so big is this level of interaction data that's being tracked today, right? In fact, I would say about 95% of this data that retailers and enterprises are collecting today are based on behavior data, right? But analyzing behavior data is very difficult, right? In fact, this is just a simple website, single channel, right? If you look at, if you're able to graph out or the user behavior, the graph on the right would depict that behavior. It's very complex, right? And so what happens, as I mentioned earlier, what data scientists have to do is take that data and then summarize behavior oftentimes, because if I want to use traditional machine learning algorithms to learn off of, I have to put everything in columns and rows, where the rows represent individual user and their profile and so on, what they did, what they bought and so on, right? So I end up doing a tremendous amount of work summarizing behavior so I can learn.
So you not only do work to summarize, but you're losing a lot of signal at the same time.
That's right. So here's another way to look at this, right? So because of that, today data scientists mostly rely on profile-based data and summarizing behavior. And oftentimes too, if you think about the questions that you're answering, right? What will the consumer do next? That's really a sequence-based question. What will they buy next, right? And sometimes the questions then gets redirected to ask, what will they also purchase, right? So a lot of recommendations are more based on that kind of idea. They bought this, they will also buy something, rather than asking, since they bought this, what will they buy next, right?
Yeah, this is typical, like, you know, when I buy a TV on Amazon, I mean, Amazon's doing better, but you buy a TV on Amazon, I just spent $2,000. The first thing it recommends me is buying another TV, right? That's not exactly what I'm going to. I'll probably buy a DVD after. After, if I buy a 4K TV, I probably want to buy a 4K DVD.
That's right. So that's the idea. It's what will they do next? And you touched on this earlier, right? So let's take two examples here, illustrating a user and their set of experiences that led to a phone call. Right? So this is a sequence of interactions that led to a phone call. Another user, different user with a different set of interactions, right, across the same channel, but led to a purchase, right?
Yeah.
So if you had to summarize this into just simple frequencies, they would look really exactly the same. They all had the same number of web interaction, mobile interaction, and so on, right? Mm-hmm. And so it's hard to distinguish end result based on their prior experience, right? Because it looks the same when you summarize it, and that's what this is depicting here. And so what we realize is that when we talk to data scientists at various large corporations and so on, they really want tools that would help them to understand this behavior data better. Right? And that's why we created GRASP. Really, GRASP is a concept where you can take event data from disparate sources. As long as you can identify the unique user ID and timestamp, we can ingest that and create event views. So these are some examples where you might get those event data. Google Analytics is, for example, here, right? Where actually we took event view prod as one of the outputs from that data, and then this is what the event view prod in terms of insights would look like, how we would use it. We would use a user ID and timestamp to come off of this, right? So that's a web visit, right? This is using a hotel search data, for example. Again, user ID and timestamp, what they looked at, what pages they looked at, what they searched on, right? This is all behavior data, right? And then this is depicting API data, right? So,
and there's a lot of API data flowing through Apigee, right? So that already bootstrapped you for building a lot of these models, right?
Right. So again, if I wanted to take that a little deeper, so once the data sets are joined by user ID and timestamp using our tool, underlying technology then creates what we call this event-based behavior graph, right? So rather than storing everything in a relational data store, we're actually creating an event-based behavior graph where each node represents interaction, and each interaction then also is characterized by attributes. What did they do during the interaction, right? And so this is really the secret sauce then that we apply. We create an aggregated behavior graph based on combining users with similar behavior, and then we apply Bayesian machine learning on top of that, okay, to create those predictions. So what we're doing is really creating these micro segments of behavior clusters and then learning off of that.
So there's a couple of innovations I just heard, right? Number one is you can take any type of event data source.
That's right.
You can take any kind of profile data. It doesn't matter what your CRM system is, whether it's Salesforce or whatever. And then we're underneath the hood, we have a specialized graph database on top of Hadoop, specifically around event data, so that you can and then we apply machine learning on top of it.
That's right.
To actually go build out these predictions for the next next best action, or figuring out email to send the person, etc.
Right.
But the cool thing is that all this stuff is just all hidden, right?
Yeah, right. In that ARC script that I showed you, there's a simple execute model command, right? And that's it. But underlying it, that's what's happening, right? Creating the graphical data structure and so on.
So let's see if there's a question. I see a question here. What is the need of a behavioral model generated by RStudio?
Oh, okay. That's a good question. I think I can answer that a couple of ways, but first way is, if you don't have, maybe I would illustrate this. Let me see if I have something like that. Okay, I'm going to show you this. So this is sort of a typical actual interaction data. This is purchase interaction across multiple merchants. In fact, this is the data that I use to build out the mobile app, right?
Yeah.
What you see here is user ID, timestamp, and what they bought, right? Who they interacted with and how much they spent, right? It's a time-based transactional data. How do you go from this in a traditional modeling approach, right? How do I build a predictive model that says what are they going to do next, right? Where everything has to be in columns and rows, where each row represents one user and what they did, right? But in this case, you have multiple records for each customer, right? So the data structure itself, first of all, it has to be converted, summarized into the tabular data structure to do modeling. So the R script, if you remember, I simply just pointed to the raw transaction data, identified the user ID and timestamp, and then it learns the behavior, right, of the sequence of interactions that are here automatically, right? So, so it's that traditional approaches, it's hard to use raw transaction data like this to learn off of, right? So that's one reason why.
Okay, cool. See if there's any other questions. Okay. So another question that I had was a little bit more basic one. It was like an email that came in like, how do we get data into the system in the first place?
Yeah, that's a great question. In fact, there's a couple different ways. And when you sign up for the account, there's going to be data already loaded, but we also make some data available for you to actually do that loading yourself. So one simple way is to use the GUI-based approach. So if you go to data, let me share it. Import data, it'll walk you through. It's a step-by-step approach. Where's your interaction data stored? If it's in the CSV, you can do that. And then that's for doing like quick out-of-the-box demos and things like that, like quick analysis, but also it runs on, so we have an instance running on AWS, so you can actually just point to, load data to S3 bucket and then access all that, if it's larger data set, right? Yeah. You don't want to be moving around, so.
Yeah, and on inside, when you install the Insights, we didn't talk about deployment a whole lot, but Insights it comes in two flavors. One is on AWS, one is in the cloud, where your batch interface is S3, so you can move data in and out of your via S3. And the other way is you can deploy it on-prem on inside your own data center or in your own private cloud instance, which is useful because if you have a data lake or enterprise data hub, you can load Insights on top of your existing Hadoop cluster where all your data lives.
Right.
And one of the core mantras of Hadoop is don't move data. Right. So you can actually run all your machine learning and your scoring and all these analytics on top of your existing Hadoop cluster where your data is. So you're not only going to get the performance, but you're also going to get the you're also going to have the security aspects to it too. Now in the cloud, because we leverage, that being said, not everybody wants to run their own, either they don't have an enterprise data hub, or they don't want to, the cost of moving data is not as high. So we also have a cloud instance where you can quickly move data in and out from whether it's your data warehouse. Yes, we do support FTP. So if you have an old school data warehouse, we can't pull that in. Or if it's Hadoop, we support very high bandwidth inputs and outputs into our cloud system.
Also, can you talk about the real-time aspect, right? We kind of showed a couple of our demos how we do real-time updates, recommendations, and maybe architecturally what that looks like.
Sure, yeah, I think there's a slide there that kind of describes it. So, yeah, so there's, you know, this is coming back to, there's a pretty famous popular architecture, especially in the Bay Area, called Lambda architecture. And what the idea is that you want to separate the types of processing into, and use the technology that's appropriate, aka your batch layer for doing a lot of heavy-duty machine learning, and then your speed layer for doing your speed and real-time serving layer for doing your real-time interactions, right? So the way it works is that the batch layer where Insights is running is doing all the hardcore machine learning. It's generating the lists of users who needs to be emailed out to. It's generating the list of recommendations on a per user basis for that. And it's pushing the data into the serving layer. And the serving layer is then fronted by Node.js applications, which Apigee Edge allows you to upload very easily, to tie the data not only with the predictive models, not only the predictive scores coming out of Insights, but also your other systems of record. So whether it's your ERP system, your product catalog, or other recommendation systems out there. You know, a lot of our retail customers already use Rich Relevance. We have a lot of customers that are proxying Rich Relevance through our platform already, or integrating with other analytic systems such as you may already have your own Hadoop-based algorithms out there. So kind of like, you know, showing end-to-end, you got raw data, customer data coming in. You have an analytics engine, which is doing all the heavy-duty analytic machine learning and pushing it into the serving layer. And then the serving layer interacts with all your devices, your email channels, etc. Also leveraging in context to serve the best results. Okay, so we're pretty close to time. Let's see if there's any additional questions. Okay. So I think this is a good place for us to stop then.
Yeah. So thank you for joining us.
Thank you. A reminder. So we have a I Love APIs conference. If you're into APIs, if you're into big data, if you're into digital strategies to help increase engagement, we'd love for you to come October 12th to 14th. Thank you very much.
And there's a 15% discount actually on here too, so please take advantage of that.
Take care.
All right.
Thank you.
Thank you.